This is a video about the complement rule, and we'll also cover the at least one shortcut. First, the complement rule. The complement rule tells us that all probabilities always have to add up to 1. So if you take all the possible outcomes for any situation, the probabilities always have to add up to 1, or we'll write in there, or 100% if you're dealing with percents instead of fractions or decimals. So for example, let's say we have a certain kind of candy and we know the probabilities for each color are, say, 0.25 probability for a red or 0.15 for a blue. So let's look at our table and say, what is the chance of getting a red candy? Well, to get a red candy, I just look at red, and the probability of red equals 0.25. So that was pretty simple. But now, what is the chance of getting a not red candy? There's two ways you can do this. You could do it by hand or the long way. You can say, well, if I don't want red, so like the probability of not red, well, that would just be the same thing as probability of blue, or I'm going to start abbreviating yellow, or green, or purple. And then I'd have to go through and add all of those up. So I'd have to add basically all of those other colors. So 0.15 plus 0.05 plus 0.35 plus 0.20. So I'm adding up the probabilities for every color that was not red. And I get 0.75. So that's the probability of a not red. That's the long way. Or I can do it a shortcut way. I can use the complement rule, and I can say, oh, well, if the probability of red equals 0.25, then the probability of not red is just 1 minus the probability of red, or 1 minus 0.25, which equals 0.75. Because again, we know that all probabilities always have to add up to 1. So if I know the probability of red is 0.25, instead of finding the probability of everything that's not red, I can just do 1 minus the probability of red, and that gives me 0.75 is the probability of not red. So the complement rule is all about being a shortcut to save you time. If you know one probability, then the probability of everything else is just 1 minus that. Let's try a few more examples. If the chance of picking a person with a college degree is 40%, then what is the chance of picking someone that does not have a college degree? So if we want the probability of not college, then that would just be 1 minus the probability of college. So 1 minus, we said college degree is 40%. Now you can do this different ways. So I said 1 minus, but we're dealing with percent, so instead of doing 1, we'll do 100% minus. So 100% minus the probability of college, or 100% minus 40% equals 60%. So if 40% have college degrees, 60% do not. Let's see, in Remley's car there are 15 CDs. If there are 14 country CDs, what is the chance of picking a CD that is not country? So the probability of country, we said there were 4 country out of 15, so we'll say 4 out of 15. So if we want the probability of not country, I don't have to know everything that's in there. I just have to know that it has to add up to 1. So we'll just do 1 minus the probability of country. So 1 minus 4 out of 15 should give me 11 out of 15. Again, when you're doing this math, I don't care if your final answer is in decimals, fractions, percents, anything you feel comfortable with. Whatever your calculator gives you, it's all okay. Now we take that complement rule and we say, let's use it anytime we're asked to find the probability of at least 1. Because you can do these problems different ways, but it's going to be faster. Every time you're asked to find the probability of at least 1, you'll just do 1 minus the probability of none, because the opposite of at least 1 is actually 0. So at least 1 includes 1, 2, 3, 4, 5, 6, 7, 8. The opposite of that is just 0 or none. Let's try an example. Suppose in a certain town you have a 0.45 chance of meeting a person who is renting, and everyone else in this town owns their home. So first of all, what is the chance of meeting someone who owns their home? Well, I would use the complement rule of, we know right here, so the probability of rent equals 0.45. So the probability of own is going to be 1 minus the probability of not own, which is basically just rent. So we'll just do 1 minus 0.45 equals 0.55. So that was the complement rule there. Sometimes we have to use the complement rule twice in one problem. Let's try part 2. If you meet 3 people, what are the possibilities for if they rent or own their home, and find the chance for each possible outcome? So this is just a preliminary step. This is something we haven't shown you how to do. It's not something you have to do in this class. We do in other and more advanced statistics classes. But I'm going to show you so that this at least one rule makes sense. So this is all here to help that at least one rule make sense to you. So when I meet the first person, I'm going to do a tree diagram. My first person can either rent or own their home. And then if I meet my next person, they can either rent or own that home. And if the first person had actually owned, then the next person could either rent or own. And then for each of these possibilities, the third person can either rent or own, rent or own, rent or own, rent or own. So this is called a tree diagram. Again, it's not something you have to know in this class. The reason we write it out is because it helps us keep track of what all of our possibilities are. So as I follow along, one person could do a rent, rent, rent. So my 3 people could be rent and rent and rent. So I'm going to write this here as my possible outcome. I'll say rent, and then the next person could be rent, and the next person could be rent. Or I could follow a different branch along the tree. I could say rent, rent, own. So then I'll write that here, rent, and own. You'll notice I get tired of writing out the entire word and abbreviate. The next person, or my next branch says, well, we could pick the first person to rent, the next person own, and the next person to rent. So it would be rent and own and rent. Or we could have got a rent for the first person, and then an own, and then an own. So rent and own and own. And I just keep going down through the tree, and I say, well, what if we have own, rent, rent, or own, rent, own? And we figure out all the different possibilities. You'll see in the table, I started to fill this in for us just to make time, save time. But now that we know what all of the possibilities are, in this class, we do know how to find those chances. So like if I want the chance of rent and rent and rent, well, the chance of renting is 0.45. For an and, we multiply. And then we want the next person to rent, so that would still be 0.45 times. And then the next person we want to rent, so again, 0.45. And I put that into my calculator to get 0.0911. Now if I wanted rent and own, well, rent is 0.45, and then we'll times it by the next person of 0.45, and then we'll times it by the next person, which we actually want to own. And in this first part, we said to own is 0.55. So we'll say 0.55 now, and that changes my probability to 0.1114. So if I want rent and own and rent, well, rent is 0.45. We do a times because it was an own, because it was an and. For own, we do 0.55, and for rent again is 0.45. So put all that into your calculator, 0.1114. Notice these do match up. That often happens in situations like these. Let's see, rent and own and own. So rent is 0.45, own is 0.55. And we want another own, which would also be 0.55. If I put that in, I get 0.1361. And then I did the rest just to save us time. So now that I've done all that, let's do another preliminary step and say, well, what is the chance of getting no renters? So that's 0 renters. Well, the only way to get 0 renters, if you look at all of these outcomes, there's only one outcome right here that has 0 renters. So the only way to get that is the probability of own and own and own. Sorry, those are owns, not zeros. That might be confusing since I did a 0 there. So own and own and own, which is that 0.1664. Now that I've done all this preliminary work, we're going to figure out how to get the chance of getting at least one renter. This is what the whole video has been building up to. Why I'm going to show you, why does that at least one rule make sense? Why do we use it? So what is the chance of getting at least one renter? You can do this a long way or a short way. So long way is you say probability of at least one rent And you'd have to go through and you find all of the outcomes that are at least 1. So all of the outcomes that are at least 1 would be these basically top 7. So I need to take these top 7 and add them all up. So I would have to do, that's the probability of rent, 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 and rent, and rent. Or, so we'll do plus probability of rent, rent, own, plus the probability of rent, own, rent, plus the probability of rent, own, own, plus the probability of own, rent, rent, plus the probability of own, rent, own, plus the probability of own, rent. Did I get them? 1, 2, 3, 4, 5. Okay, so we have all of those that we have to add up. Now in this case, there's only 7 of them. If you get more complicated problems, so instead of looking at 3 people, you look at even 5 people, you start getting to hundreds of possible outcomes. No one wants to add up hundreds of possible outcomes. So that's why we really like this shortcut rule. But for this, we're going to add up our 7 outcomes. So rent, rent, rent was 0.0911. So we'll do 0.0911 plus 0.1114 plus 0.1114 plus 0.1361 plus 0.13, no, 0.1114 plus 0.1361 plus 0.1361. If I wrote them all down correctly, I put it all into my calculator and I get 0.8336. So you can do at least 1 the long way, but you have to find every other possible outcome for at least 1. So all the rent, own, rent, all the different possible outcomes, and you have to add up all of those probabilities. And even with just 3 people, this can take a long time. Okay? With more than that, you could be working on this for days. So we came up with a shortcut. The shortcut says the probability of at least 1 rent is equal to the 1 minus the probability of no renters. And how do you find the probability of no renters? Well, we already found that right here. It's the probability of own and own and own. So 1 minus 0.1664, which gives me 0.8336. So we've used this quite a few times in our videos already, but I always have students saying, why? Or this doesn't make sense. This is how it makes sense. Okay? Is you look at it like this, you say, well, what would all the other possibilities be? Then you realize it's a lot easier just to do 1 minus the probability of none or no